So, happy snow day. So I'm trying this for the first time, this meeting with you electronically business. So let's see how it goes. Okay, first of all, I'm going to finish up 1.6 on this video and then see what the time looks like. So I want you to be familiar with the following trig identities. These guys right here. Okay? It's okay if you don't know them by heart, but you know where to look them up and you know how to use them. So it means if you have, you want to split an angle up. Let's say we want to, make sine of 15 plus, we don't have sine of 15. Let's try the sine of 30 plus the sine of 45, for example, or something like that. Then we know sine of 30 and sine of 45, so we can find out sine of 75. Or similarly, we could say 45 plus negative 30, where b is negative 30, then this works too. We could find the cosine of 15 using the law of these double angle formulas. Well, these sums formulas. Okay, so it's sum and differences. You don't have to memorize both formulas because when you flip the b, okay, if this b becomes negative b, cosine doesn't change, so that formula doesn't change. Sine of b, this becomes a minus there. Alright, so if you made this a minus, this sign would flip. If you made this a minus, what happens? Well, it's sine that changes. Sine. So then this would turn into a plus. So in the middle sign would also change. Okay. You should also recognize that sine 2t and cosine of 2t just comes from these formulas above. Let a equal b equal t, and you immediately get those formulas right there. Okay? So really the only ones you got to remember are those guys, or know where to look them up. Law of sines you should pretty much have by memory. And law of cosines you should have by memory. Again, these things are prerequisite material from 170. And so I expect that some of you will be rusty on some of these facts, and so I might provide it on an exam, or I'd give you a warning in advance. I probably would not expect you to know it cold. And even if I did give it to you on an exam and you freak out, then you just put your hand up and say, hey, I forgot the law of sines, and I'd say, oh yeah, I bet everyone did. I write it on the board. So also during exams, if you freak out, don't freak out. Just come talk to me. I can usually give you a hint, and if I give you a hint, I share it with the class. Okay, so this is the triangle we're talking about in terms of law of sines and cosines. I wanted to point out that whatever you're calling this side over here, the name of the angle across from it has, you're either using capitals and lowercase or lowercase and capitals. So this law of sine means that if you take any triangle and take the ratio of the sine over the side, for all three triangles, it's going to be the same ratio. Isn't that crazy? I think it's completely crazy. And also, why do we put sine on the top instead of the bottom? Well, that's easy, because people didn't used to have calculators. And so it was easier to look up sine of A on a table and divide by 3 than to take 3 and divide by the sine of A, right? But the law of sines is perfectly valid mathematically if you flip all these, as long as you flip all of them. Okay, law of cosines, same deal. Cosine of C. Okay, this cosine means, the only thing it means is you have to be opposite of that side. And you may say, but there's two other forms of the law of cosines. Yeah, I know, but you can just relabel your triangle. So there's no point in memorizing it 3 times. You're just relabeling the triangle. Okay, so that's trig in a nutshell. Let's go to some problems about logs. So we are going to condense the logarithmic expressions below. Okay, so we're looking at this minus here, and that's going to be a divide, and the plus is going to be a times. So first, let's first get rid of these exponents here. Put the exponents up front. They're up front, make them exponents. I said that backwards. Okay, so we want to put everything into one Mondo log format. The divide by 8 to the 6th and 17 to the 7. Okay, just condensed everything. Log y to the x minus 2 log, why did I do this? X squared. I'm rewriting it so that I do it correctly. Log y cubed. There we go. Okay, so this is just going to be log y to the x divided by x squared and then plus y cubed. I mean, you can combine these. You can say log y x plus 3 over x squared. This is an optional step. Okay, next question. Expand these expressions. So you're going to just do the opposite of what you just did. Those are easy. Log x power is 1/3 plus log y power is 2 minus log of z. These ones are actually easier because there's fewer ways to untangle them than to tangle them. I can up here I can change the order. See how I changed the order of these guys around? So I had to do the denominator and then the numerator. Okay. This one I'm going to expand. So I'm going to go x log 3 plus 3 log x minus 2 log y. Okay. Next question. Find the exact values. So what this is saying is, remember our rule. That means log base is 5. And it's asking us for this number. And we know that equals 3. That's it. It's saying, what is the exponent in base 5 of 125? Well, that's 3. Here's another one that looks kind of easy and hard at the same time. Okay, log base 10. So what's the exponent in base 10 of the square root of 10? And then you say, oh, well, that's easy. That's just 1/2. Yep, it is easy. And what about this one? Well, we're just using the formula in the other direction. So equals some quantity. Let's figure this out. Natural log of quantity is equal to minus 2 natural log of 5. Okay. Now what do you do? Well, you look for a different way out. The thing you should be looking for is e and natural log should be combining somehow. And this is not the quickest way to deal with this. So we just say, never mind. Then you say e to the natural log of 5 to the negative 2, and then you're home free. Okay? So you could even write it like this step is optional. Okay, because it was already exact here. Okay, so it's okay in math to back up and say whatever I did was true, but it makes absolutely no sense. It means it just doesn't go anywhere useful. But it was the natural thing to do because we were just using the formula up above. Okay. Sketch without the use of a calculator. Well, this is a graph shift. Well, this is already a bad plot. Why? Because I'm going to have to deal with negative values, and I don't have myself set up well to do that. It's a little better. Okay, so we always think natural log of 1 is 0. Well, log base anything of 1 is equal to 0. So log, in this case, y of negative 4 is equal to 0. So we put it on the plot. And then, well, we always want the other axis. So y of 0 is log base 10 of 5. Okay, so it's going to be somewhere here. Log base 10 of 5. But that's not very satisfying. We want to use some points that we know. So first of all, we know that at -5 we're going to have an asymptote. So at least we know that much. We know that 5 to the 1 is equal to 5. Oh, I meant 10 to the 1 is 10. So log base 10 of 10 equals 1, but this occurs when y equals 1 and x equals 5. So if x is 5, I should put it out a little further than my 4 in the other direction. So maybe this is 1. Well, I have a calculator. I can find out what log base 10 of 5 is. I can say log of 5 equals, oh yeah, so this is like 0.7. So this is what's happening. We're getting this really steep curve here. And then this is 5, 1. And if you want, you can also include 95, 2. For the same reason, it's just shifted over. This asymptote shifts everything over. If we hadn't shifted this over, this would be 100, 2, 10, 1. You know, it would have been like that. Okay? And I'm going to pause for a second. Okay, moving right along. We want to do e to something. So what I see here is this 1000 is not going to change the shape of my plot, and this multiplier is not going to change the shape of my plot. I'm just going to plot e to the x, just like I normally do. And then all I have to do is change what's going on in this plot. So this is usually 1, but now it's going to be 1000. If it's not a financial question, we include the whole graph. If it's a financial question, we start at t equals 0. Okay? I should probably put in another point. So I'm just going to put in, let's say, t is equal to 10. This kind of looks like it could be financial. So let's try 1000 times e to the 0.5. So it looks like we're investing $1,000 compounded at some continual rate to the power, but not necessarily. It could be a pure problem. 1648 or 1649. So that's just so that you get a general idea of what the curve is supposed to look like. Okay? The only asymptote is this horizontal asymptote. You don't have to draw it because it's the axis. If the asymptote is somewhere else other than an axis, you have to draw it. And yeah, that's basically it. Okay. Well, this video is longer than I want it to be, but I'm sorry about that. I was going to cut it, but I don't have a really logical place to cut it. Okay, find x. Alright, so if I want to find x exactly, I have to raise e to the power of both of these expressions, and that releases that 3x minus 10. It offloads all the weirdness to e squared, but it looks a lot easier to deal with over there, because then I can just add 10 to both sides and divide by 3. Yay! Next question, log of x is 1, find x. Well, alright, let's e to the stuff first, right? So then you get one of those natural logs comes out, but the other one's still there. So then you go e to the stuff, so you actually get x is equal to e to the e. Too cute. See, this problem was in your book. I hadn't seen it before, so I picked it for you. Okay. This question is going to be a hold on to your chairs if you haven't seen it before. Okay, so maybe I'll pause here and then I'll start a new video.